Chapter 7, 7.2, Higher Degree Polynomials. As we look at this polynomial, we can clearly see it is in its general form. From its general form, we can easily look at this highest power exponent, and therefore know that this is a fourth degree polynomial. Now, as I look at this graph and look at this polynomial, I wish to write it in factored form. When writing polynomials in factored form, I already know from previous lessons, I need to look at my roots, the x-intercepts. And I can see here, I clearly have 3 x-intercepts. But this is a fourth degree polynomial. That means I should have 4 roots. Well, what we're learning new here is that if we see this bounced shape on a graph, the root associated with it is known as a double root. Now, if I were to list all my roots out, I would have x is equal to negative 4, x is equal to negative 4, with negative 4 being my double root. But then I also have 2 distinct roots, and x is equal to 3, and x is equal to 5. Now that I know my roots, I can begin to use my factored form of y is equal to a multiplied by x minus r1 multiplied by x minus r2 multiplied by x minus r3 multiplied by x minus r4. As I look to fill in my y is equal to a, well, since up here I have the general form, I know the leading coefficient of 2 is my a. So I have 2 multiplied by x minus first x-intercept. So minus negative 4 is x plus 4. Yet again, x minus negative 4 is x plus 4. And yet again, x minus 3, x minus 5. Now, my factored form is almost complete, but I would like to combine some like terms to make this look even neater. So I'll have y is equal to 2 multiplied by x plus 4 squared. I find this because x plus 4 times x plus 4 is x plus 4 squared. I multiply that by x minus 3 multiplied by x minus 5. And this is the proper factored form of this polynomial. Now that I have identified my factored form, I would like to check to make sure this is equivalent to the general form. So, the first move I must make is I must distribute my 2. So, y is equal to 2 times x, which is 2x, and y is equal to 2 times negative 3, which is negative 3. So I would find y is equal to 2x minus 6x. And I would also need to bring down my x minus 5 and my x plus 4. The next step I would like to do is I would like to FOIL 2x minus 6 and x minus 5. Well, 2x times x is 2x squared. 2x times negative 5 is negative 10x. Negative 6 times x is negative 6x. And negative 6 times negative 5 is positive 30. So if I were going to go down to my next step, I find that this is true. but I also need to bring down this x plus 4 squared because I haven't done anything to it yet. Now I would like to combine like terms to find 2x squared minus 16x plus 30 is multiplied by x plus 4 multiplied by x plus 4. And in this step, what I did was I broke apart my x plus 4 squared so I could see it much more easily so that I can FOIL it in my next step. So x times x is x squared. X times 4 is positive 4. X times 4 is positive 4. And 4 times 4 is positive 16. And I see that clearly in this step. Since I did nothing to my first term here, I just bring it down. Now we'll combine like terms. And now I need to begin distributing. So, 2x squared times x squared, 2x to the 4th. 2x squared multiplied by positive 8x plus 16x cubed. 2x squared multiplied by this 16, 32x squared. Now I need to distribute my negative 16x. So negative 16x multiplied by x squared is negative 16x cubed. Negative 16x multiplied by 8x is negative 128x squared. Negative 16x multiplied by 16 is negative 256x. Finally, 30 times x squared is 30x squared. 30 times 8x, 240x. And 30 times 16 is 480. Now after I combine like terms, I would find my general form to be y is equal to 2x to the 4th minus 66x squared minus 16x plus 480, which in fact was the general form that I started with. Let us analyze this graph as well. I wish to find the factored form of this polynomial. So the first thing I need to do is find my roots. I see I clearly have a root here. I have a double root here because I can clearly see it just bounces off that x-axis, and I see I have another single root right here. So, my roots are at x equals negative 4. I have two roots at x is equal to 3, and a root at x is equal to 5. Simple enough, I can write this in my factored form. Y is equal to a. Well, I know up here my a is 2 because they gave me the polynomial in its general form. 2 multiplied by x minus the first intercept. X minus negative 4 is x plus 4. X minus 3. And I have another root at x minus 3, so I can just write this as x minus 3 squared. And I can multiply it by my final root at x minus 5. And that is the factored form of this graph. Much like we did with the first example, I've also demonstrated to you the algebra associated with moving this graph, this polynomial from its factored form to its general form. You may want to take a second at this moment to pause the video and review this algebra. If you have reviewed this algebra, we can easily see this is a 4th degree polynomial, but it only has 3 x-intercepts. The root x3 is called a double root because the factor x minus 3 occurs twice. And we can easily see it occurs twice because of it having the exponent 2. The roots that occur once, you can think of each having a 1 as their exponent. This example introduces yet another new root to us. As we see here, this graph makes this odd turn, but it does cross the x-axis, so I do have an x-intercept here. This is what we call a triple root. So I have 3 roots at -4 as I look at this polynomial. I can continue on and I see I have a root at 3 and yet another root at 5. So if I'm to list out all my roots individually, my roots are x equals -4, -4, -4, 3, and 5. As we've been doing in this lesson, I would like to write this polynomial in its factored form so I can use these roots to aid me. Its factored form will be y is equal to a. So I look in our general form, I see a is equal to 2 multiplied by x minus a -4, so x plus 4. And I have this root once, twice, 3 times, so I can simply write this as x plus 4 cubed. Multiply that by my next root, x minus 3, and x minus my final root, 5. And that is the factored form of this polynomial. You may want to take a second on this page to pause this video and look at the algebra associated with moving this polynomial from its factored form to its general form. This is in fact a 5th degree polynomial, but it only has 3 x-intercepts. Therefore, the root x is -4 here is called a triple root because the factor x plus 4 occurs 3 times. We can see that up here because the factor x plus 4 is cubed. Now, let us take a look at this 6th degree polynomial. When looking at this graph, I'm going to look to see where my x-intercepts are. So I see at one x-intercept I have that strange turn. I see one of my x-intercepts go straight through the x-axis, and my final x-intercept here just bounces off the x-axis. So I know here I have a triple root. Here I just have a single root, and here I have my double root. Now, if I wanted to write this in factored form, I could easily see that my a is equal to 2 from my general form, and I would simply fill in where my root is 3, where my root is 5, and where my root is 4, -4. As I see, my root of -4 occurred 3 times, my root of 5 occurred twice, and my root of 3 occurred only once. This totals to 6 roots, and thus it's a 6th-degree polynomial. It only has 3 x-intercepts, and the root of x is equal to -4 is going to be my triple root. The root of x is equal to 5 is my double root. And that is how I would analyze this polynomial. In conclusion of what we've learned today, a factor raised to the power of 1 results in an x-intercept that crosses the x-axis. A factor raised to the power of 2 results in an x-intercept that bounces off the x-axis. A factor raised to the power of 3 results in an x-intercept that crosses the x-axis in a curved fashion. If the power of the factor is odd, the graph crosses the x-axis, whereas if the power of the factor is even, it touches, but does not cross the x-axis at that value.